Hey there guys! Today we are starting some new content with parallel and perpendicular lines. This is completely new at year 10, but don't stress, we will go through it bit by bit. So on the screen right now we've got some definitions. Parallel lines are two lines that go in exactly the same direction. So if I draw that out, we've got two parallel lines. They're never going to meet, they go in exactly the same direction forever and ever, okay? What this means is that two parallel lines will have the same gradient, okay? So they have to increase in the x at the same rate as the y for both lines. Perpendicular lines, on the other hand, will intersect every single time if I've got two lines at right angles, okay? So always, always, always at right angles, okay? We've got a rule here that will help us determine whether or not two lines are perpendicular. So we'll give it a shot. We're going to write a rule for the line which is parallel, okay, to y equals negative 4x plus 3 and has a y-intercept of 2. So we know that our y-intercept, okay, that's our c value, and we've always got the rule y equals mx plus c. So the only thing we need now to write a rule for our new equation, if you want to call it y2, you can, okay, is the m. So y equals mx plus, and we know that c is 2, okay? Because it's listed in the question. Well, up here in the definition, two lines will be parallel if they have the same gradient. Well, if this rule has to be parallel to this one, then the gradient has to be the same. So the rule is y equals negative 4x plus 2. So two parallel lines will have exactly the same gradient, that is the number in front of the x, or the coefficient of x, will be the same for both lines. The y-intercept is the only thing that is different, okay? Let's try a perpendicular example, okay? So, we now need to find the rule for a line which is perpendicular to y equals 5x plus 8. And passes through this point. So there is a little bit more maths involved. The first thing that we need to do is find the new gradient. Okay, so I'll write that down in another color for you. Step 1. Find the new gradient. Okay, let's give that a shot. So we've been given a rule. M1, so the first gradient, times M2, the second gradient, equals negative 1. Okay. So, this here, this is going to be our M1. Okay, so M1 times M2 equals negative 1. We'll substitute in this 5 times M2, not M squared, M2, the second M, equals negative 1. If we rearrange that, we get the second gradient, which is the one that we're looking for, is negative 1/5. So I'm just going to write a little rule up here. This is where I'm going to fill in my blanks, okay? That's where my M is going to go, which we've just found to be negative 1/5 x plus, and we don't know what c is yet, okay? So I'm just going to write a c for the moment, and I'll erase that later when I'm ready. Now, a slightly new rule to substitute in and find our equation for the new line, okay? We've got this rule here. So y, take y1 equals m x take x1. Alternately, we can actually just substitute our 2 points into this equation. Actually, we might do that instead because it is easier and it corresponds better with what we've done in the past. So let me just erase that line entirely. I'll add a note for that at the end of this video if you would like to know how to do that. So to now find c, okay, we're going to substitute the point. So step 2, sub the point given to find c. All right, so our y-intercept. So let's do that now. So we've got here the rule y equals negative 1/5 x plus c. I'm going to write it in proper math speak as well for you all so that you can really clearly see what's going on and how I do expect for you to be writing out. We're going to say let, so we're substituting. I don't mind if you use the word sub x, okay, but let x equal, here in the point, 5, and y equal 2. So 5, 2 is the coordinate given to us here in this equation. So we'll substitute these points in. We now get 2 equals negative 1/5 times 5 plus c. Well, 1/5 of 5 is just 1, so we end up with negative 1. So c equals, let me grab another colour pen again, just to show the steps. We've now got negative 1 plus c. The opposite of take 1 is plus 1, so we'll add 1 to both sides. Okay, and we get c equals positive 3. Okay, so our rule is, I'll get rid of the c up here, y equals negative 1/5 x plus 3. Okay. Alternatively, and this is where you can switch off and start the work if you would like, or if you would like a different formula because you're like, what the heck? You can also substitute in at this point here. Instead, you could use this formula here. So y equal, not equals, y take y1, my bad. Y take y1, so where y1 is the coordinate up here, equals m, which you've just found in step 1, bracket x take x1. Okay, so where this here coordinate, in this example only, 5, 2 is x1, y1, okay, and m you found in step 1. So it is totally up to you which of these methods you use. I would prefer that you use this one because it is consistent with what we were doing later last term. But if you would like to set yourself a challenge or you want to give this a shot, you are more than welcome to. You basically would then just expand and simplify. This, however, is the recommended step. I probably wouldn't really bother with the other one personally. So use this version here. Okay? That's going to be much easier than this. But this here must be your first step. So find the new gradient by substituting into this rule here, which is very important. Okay, so that bit there. All right, give it a shot for yourselves. Let me know if you have any questions, of course, and I will be running a conference on Teams tomorrow to answer questions and help you out with individual problems. Follow the step-by-step working here. Parallel lines are nice and easy. It's perpendicular lines that you might come across some trouble with, but please just follow this step-by-step model. Until then, good luck, guys, and here if you need me.